Question 6. Each graph shown represents a transformation of a parent radical function. Which graphs represent functions with an odd index? And notice they say graphs, so we're going to have more than one answer. So recall, index specifically is referring to, if this is a square root problem, the index is 2. A lot of times with square roots, they won't write that 2, but the index for that is 2. So the square root of x, this is an even index, since the index is 2. And then likewise, an odd index, this they will write would be if we're taking the cube root of a number. And obviously an odd index could be 5, 7, 9, 11, and so forth. And an even index could be 2, 4, 6, 8, any of those. But I think just graphing each of these to get an idea of what an odd index versus what a general even index graph looks like will be helpful. So let's clear out the last problem. Let's first type in the square root of x to get an idea of what an even index graph looks like. There's the basic shape of an even index graph. Look at the 4 choices. There's a couple of those that take that same general shape. They may be taller, they may have different orientations, but graph X and graph Y fit the bill of an even index graph. And then let's clear this one out, and then we're going to type in the cube root of X. Graph it. And you can kind of see a cube root index, because you can take the cube root of negative numbers, has 2 ends to it. Kind of looks like an S a little bit, kind of a flat S there, but it goes both directions because cube roots, you can take the cube root of negative numbers, square roots you cannot. So the answer to this one is graph W. That's an odd index, and graph Z.